In this video, we are going to learn about arithmetic sequence, how to find the nth term and the sum of the first n terms. Arithmetic sequence is in the form of a plus d, a plus 2d, and so on. Basically, what this means is, I'll show you an example. Let's say we have these two sequences. Which one is arithmetic sequence? Well, it's arithmetic sequence if we have the same difference between them. Let's say 1, 3. The difference is 2. Okay? 5 minus 3. The difference is 2. This one is also difference with 2. So 1 to 3, you can get 3 by adding 2. You add, to get 5, you can add 2 into 3. And also to get 7, you can just add 2. So that's what this means. But look at the second sequence. Is this an arithmetic sequence? Look at the difference. 3 minus 1 is 2. 9 minus 3 is not 2. 27 minus 9 is also not 2. So we have different values of differences for the second sequence. That's why this is not an arithmetic sequence, but the first one is. So what is A? A is called the first term, or we also know this as T1. D is the common difference, which I showed you in the example just now. The common difference for this question is 2. And the first term for this sequence is 1. So the nth term of an arithmetic sequence is given by this formula. So if you know that the sequence is arithmetic, you don't have to find the general formula like you did in the first lecture just now, but you can simply use this formula. You can go through the proof in your lecture note, but now I would like to stress on the common difference can be found by the difference between the two terms, like I showed you just now. This simply means the second term minus the first term, you get D, or 2. D is the common difference. 5 minus 3, you get 2. So this 3 is the second term. This is the first term. If we substitute in n to be 2, for example, then here we get T2 minus T1, which is equal to the D. So that's what it means. Example 4. Consider the arithmetic sequence below. Find the nth term of the sequence. Since the question already mentioned that this is an arithmetic sequence, we know that we can just apply the formula. So the formula given is Tn equal to A plus n minus 1 times D. So from the sequence given, do we know what is the A? What is the D? The A is simply the first term. What is the first term of this arithmetic sequence? It's 9. So the first term here is 9. What is the D? D is the common difference, which means you just have to subtract the second term with the first term, third term with the second term to find the common difference. So let's say you subtract 4 minus 9, you get negative 5. So the nth term, just substitute in the values of A and D there. Do you have to substitute the value of n? No, because if you substitute the value of n, then you won't get the nth term. Let's say you substitute in 3 there. That means you get the third term. Let's say you substitute 4 there. You get the fourth term. But now we want the nth term. So just leave n here. Okay? Then you can simplify this further. Expand. And you get 14 minus 5n. Okay, example 5. Find the nth term and the 300th term of the arithmetic sequence. The question mentioned that this is an arithmetic sequence, so we know what is the formula that we can use. We want to find the nth term, so start with the formula of Tn. 300th term here means we want to find the T300. So what is the first term of the sequence? The first term is 13. The common difference, just find 7 minus 13, or you can also choose 1 minus 7, whichever you like. So let's say you chose 7 minus 13, and the answer is negative 6. Next, just substitute in the values A and D into this Tn formula and simplify. Don't forget, you have to expand before you simplify. Next, we have solved the first question, which is find the Tnth term. So Tnth term here means Tn. And we have found the general formula of Tn. But then, to find the 300th term, we have to substitute in 300 into the value of n. So just simply substitute and find your answer, which is negative 1781. Next example. The 11th term of an arithmetic sequence is 52 and the 19th term is 92. Find the 1000th term. This question also mentioned that we are dealing with arithmetic sequence, so we know what is the formula involved. So the information given is 11th term of an arithmetic sequence is 52. From there, we can write T11 equal to 52. Look at the term here, 11th term. So this means T11. And the 19th term is 92. So here, they also mention about term. So this is T19. T19 is 92. We want to find the 1000th term. That means we want to find T1000. Since this is a arithmetic sequence, we know what's the formula. But now we don't know what's the sequence. We don't know what's the first term, what's the A, and we don't know what is the D. Don't worry, we can just substitute in the information given. T11 here, we know that this 11 refers to the n. Just substitute in n11 into the formula of Tn and equate it with the value of the 11th term. Simplify this and you get the first equation. Do the same thing for the next term, which is 19, and simplify and you get the second equation. To find the values of A and D, you just have to solve this first and second equation simultaneously. So look at the first equation and second equation. Both of them has 1A. So we can just simply eliminate A by subtracting equation 2 with 1. So write the second equation first and then write first equation right beneath the second equation according to their orders. And then you subtract both of this. Don't forget to write a big bracket for the first equation. Next, you can just subtract them. A minus A is just 0, 18 minus 10, you get 8D here, 92 minus 52, you get 40. So from here, you can just divide everything with 8, and that's where you get the answer D as 5. And then, to find the value of A, you can just simply substitute in D equal to 5 into the first or the second equation. Let's say you substitute in the first equation, and you get your value of A, which is 2. Remember, we are not done yet because the question wants us to find the 1000th term. So since we have the value of A and D and we know the formula is Tn equal to A plus n minus 1 times D, we can just substitute in the formula and then just replace n with 1000. Simplify this to find the answer of the 1000th term, which is 4997. Next, we will learn about partial sums of arithmetic sequence. You can go through this proof on your own. The important formula that you need to know is this: Sn equal to n over 2 times 2a plus n minus 1 times d. Beside this formula that we can use for the sums of arithmetic sequence, we can also use this formula. Usually we use the second formula of sums whenever the question gives us the last term and the first term of the sequence. Do take note that the nth term is also equal to the sum of n term minus the sum of n minus 1 terms. I'll show you an example. If let's say the first term for this sequence that I've written down is 1. So A is 1, but A is also equal to T1. And the sum of the first term is of course T1 because you have not added it with any other terms. And then S2 means the sum of the two terms. So S2 here means first term and second term added together. So here you get 1 plus 3. 1 plus 3 is 4. To find T2, you can just simply substitute T1 to be S1, okay, and then just write T2 as a subject and bring S1 to the left. So S2 minus S1 is equal to T2. So in a general formula, you can write 2 to be n. That's why to get 1 here is just n minus 1. So it's the same thing. So T2 is equal to S2 minus S1. Next question. Find the sum of the first 50 odd numbers. For this question, they did not mention whether this is arithmetic sequence or geometric sequence or any other sequence. So do we know whether this is arithmetic or not? We don't know yet. So what should we do is we have to list down the first 50 odd numbers. Well, if you want to list down the first 50, but you can also list down first few, maybe first 3 terms, and see whether this is arithmetic sequence or not. Odd numbers are nombor ganjil. So it is 1, 3, 5, 7, and so on. We want to add until the 50th term, also known as T50. We want to find the sum, so we can just add them. But of course, we don't list down until all the 50 odd numbers terms, because it will take a longer time. Now let's check whether this is an arithmetic sequence or not. To check, you have to make sure the difference is the same. So 3 minus 1 is 2. 5 minus 3 is also 2. 7 minus 5 is also 2, and so on. That means this is an arithmetic sequence. Since we know that this is an arithmetic sequence, we can simply use the formula of Sn. And we want to find the sum of the 50 odd terms. That means our n here is just 50. The only thing left for us to find the sum of 50 terms is, we know what is the n, it's going to be 50. We have to find the value of a and d. So what is the a for this arithmetic sequence? A is 1, first term. D is the difference of the two terms, which is 2. And the n now is 50. We know the values, just substitute all of them into the formula and then simplify. You get the answer as 2500. Example 8. The question mentioned that this is an arithmetic progression. Do take note. The rth term of this arithmetic progression is 1 plus 6r. So this means rth term. Term means t. It's talking about tr is equal to 1 plus 6r. That's the first information that we can get from this question. Find in terms of n, sum of the first n terms of the progression. So the question wants you to find the sum of the first n terms. Sum is just this big S of the first n terms, means we want to find Sn. To solve this question, the word arithmetic progression is the most valuable information that we need to know. Since we know this is an arithmetic progression, we can use the formula of sums, Sn, and also the formula of Tn. But now, since the question has given us the general term of this arithmetic progression, which is 1 plus 6r, then we don't have to use the formula of Tn. So to find the sum of the first n terms, we need to know what is the a and d. How to find the a, which is the first term, and d, which is the common difference. You can get it just by using the general formula of the term. And then to find the first term, you know that the first term means r is 1. Just substitute in r1 here to find your first term. So your first term is 7. Next, to find d, or the common difference. You can get it by substituting the second term minus the first term. So what is the second term? You can find it from the general formula of the terms given. Just substitute in r to be 2. So from here, you get the value 13. To find d, just subtract these two numbers, t2 minus t1, and you get 6. So here, the sum of the first n terms of the progression, substitute in your a's and then your d, solve it, simplify. Remember, you have to expand this, simplify, and then this is your answer. Well, how do you get 4 plus 3n here? Is because you can divide everything with 2. Before you divide everything with 2, make sure you factorize 2 first. Factorize 2 first, and then you can cancel off with 2 at the denominator. You cannot simply just cancel off 2 with 8 here, because 2 is divided by all of this expression, not only 8. Okay? Example 9. How many terms of the arithmetic sequence 5, 7, 9 and so on must be added to get 572? So from the previous examples, you should know that the first step, the most important step, is to determine whether they have mentioned about the type of sequence of the question. So for this question, they have mentioned that this is an arithmetic sequence. By knowing this, we know the formulas involved to solve this question. This is the sequence, and then the question wants to find how many terms. How many terms here means, is it Tn or is it n? Well, most students think that this is Tn, but this is not Tn. It means how many terms, what is the n? That's what we want to find in this question. The n, not the Tn. Because if you find Tn, that means what is the value of this nth term, not how many terms do we have for this sequence. Okay? Next, what is this 572? Is this the Tn or the Sn? Well, the keyword here is added. Added here means sum. So that means how many terms of the arithmetic sequence of this sequence that we have to add until we get a sum of 572. That means this value is the sum, not the term. But the sum of what term? The sum of the nth term. So this is the value of n that we want to find. So Sn is equal to 572. Next step, list down the informations given, also the question that we want to find. Now, since we know what is the arithmetic formula for the sum of n terms, we can just use that formula. But remember, to use that formula, we need to know what is the a and d. So the a for this sequence is 5 because it's the first term. And the d is just the common difference. 7 minus 5 is 2. But you get it from the second term minus the first term. Simply substitute in a and d into this formula and equate it to be 572. So how you arrive to this step is, after you have expanded this expression and multiply this 2, you get 10 plus 2n minus 2 divided with 2. So remember, you can factorize 2 out all of this, and then you can cancel off with 2 at the denominator. That's why you're left with this equation. Next, just expand and you get the quadratic equation. Move 572 to the left and factorize. You get 22 and negative 26 for the n. Well, what is n? N is the number of terms. Is it logic to have negative number of terms? Well, no. So that's why we only take positive number of terms. So n is equal to 22. And that's your answer. Example 10. For this type of question, we really have to understand the question first before we start answering. So the sum of the first n terms is this. So what does it mean by sum of the first n terms? Sum. Just write the big S, first n terms. So this is the subscript n is equal to 3 over 2n times n plus 7. We get the first information. Next, the question wants us to write down an expression for the sum, big S, of the first n minus 1 terms, subscript of n minus 1. How to solve this question? They have given us the general formula of the sum of n terms. That means if we want to find the sum of 2 terms, we can simply just substitute in n equal to 2, right? So just substitute the n's to be 2, and that's what you get for your sum of 2 terms. But the question wants us to find the sum of the first n minus 1 terms. That means at this n, instead of n, we just substitute in n minus 1. So substitute in n minus 1 into all of the n's there. Like this. All of the n's had become n minus 1. And then simplify this. n minus 1 plus 7 is n plus 6. And then you can just leave your answer like that. Next part of the question. Show that the sequence is an arithmetic sequence. For this question, they did not give us the sequence. They only gave us information about the sums of Sn and also the sum of the n minus 1 terms. So how to show that the sequence is an arithmetic sequence? Please do take note. To prove whether a sequence is an arithmetic sequence, you have to use this formula, Tn minus Tn minus 1 equal to D. You have to prove in general. You must leave the terms as n and n minus 1. Do not substitute in n to be any other number like 2 or 3 and so on. But to prove this, we need the terms. But now we have the formulas for the sums only. We don't know what is the Tn. But remember, we have discussed the formula that we can use, which is the nth term is equal to the sum of Sn minus sum of n minus 1 terms. So this means we can just substitute in this Sn minus with this n minus 1. Since both of this has 3 over 2, to simplify this problem, we can factorize 3 over 2 and then leave everything inside a big parenthesis. Next, expand them. Expand inside the brackets. Be careful with the negative outside of this parenthesis. Expand this negative and simplify this expression inside the parentheses. And then you get 2n plus 6. We have 2 and 6 in the parentheses. That means we can factorize number 2 to be cancelled with the 2 at the denominator. Remember, please don't cancel this or 2 with 6, because 2 at the denominator is for both terms. After you have factorized number 2 out, then you can cancel off with the 2 at the denominator and you get 3n plus 9. That's your answer for the nth term. But now we want to prove that it is an arithmetic sequence. So we also need to have the n minus 1 term. Applying the same concept, n minus 1 term simply means changing this n to be n minus 1. Just simplify this and you get 3n plus 6. To prove that it's an arithmetic sequence, you need to use this formula, which is the difference of these two general terms is equal to the common difference. Once we have obtained the n term and also the n minus 1 term, we just subtract both of this and then you simplify, you get the value of 3. To show that it is an arithmetic sequence, please write these sentences because you need to explain why it is an arithmetic sequence. So since the difference of two consecutive terms of the sequence is constant 3, therefore sequence is an arithmetic sequence. Constant 3 here means that no matter what term that we substitute in, let's say T2 minus T1, the difference is still 3, T3 minus T2, the difference is also 3, and so on. That's why we prove using the general formula of terms. We don't simply just use T2 or T1 to find the common difference and prove this arithmetic sequence. Okay, thank you for watching.